Okay, I wanted to just do a little bit of explanation about absolute values and how they relate to inequalities. Even though this isn't a major focus of the lesson in CPM, there are a few problems, and it can be confusing, but I think it's pretty cool. And so I'm going to try to just explain it using two example problems. This first one I think was from number 30 from a few days ago in section 9.1.3. And it's asking to solve the inequality x minus 2, the absolute value of that is less than 3. Now, the way I like to think about this is absolute value means distance from 0. Now, when you have the absolute value of something equal to a number, then it's exactly a certain distance from 0. But when you have the absolute value greater than or less than a number, it's saying there's a range of numbers that it is away from 0. And on top of that, it's not just a variable away from 0, it's variable minus 2. So here's the way I like to think about it, and different people explain it in different ways. The thing inside the absolute value symbol is what has a distance of less than 3 away from 0. So I go off to the side here and I think, what are all the numbers that are less than 3 away from 0? So there's 0, there's 3, there's negative 3. Well, to be less than 3 away from 0, it's going to be numbers like 1 and 2. Those are all in the range we're talking about. But so are negative numbers like negative 1 and negative 2. So these are the numbers between negative 3 and 3 that fit our definition of less than 3 away from 0. And so I use this to set up not one but two inequalities, because there's two situations going on here. One is when x minus 2, the stuff inside the parentheses, is less than 3. That's one situation. But we have to also rule out, it can't, just because it's less than 3, negative 100 wouldn't work because that's not close enough to 0. So we have to have this situation where there's an overlap of two situations. So it's both numbers that are less than 3, and at the same time they also have to be greater than negative 3. And I put this and in caps and underlined it because the word and in math and really in English language means that both of these things have to be true at the same time. And you'll see what I'm talking about with the next example, what other option we have. Then it's just a matter of solving each of these. So you add 2 to both sides, and you get x is less than 5, and x is greater than negative 1. So those are the numbers that, if you put in to the original inequality, will make it true. And what that looks like on the graph, when we actually graph our solution, is there's 0, there's 5, there's negative 1. We're looking for all the numbers that are less than 5, but they have to be also greater than negative 1. That's where the and comes in. So it's going to be up until negative 1. So there's our inequality and our graph. Okay, so I'm going to do the exact same problem, except instead of less than 3, I'm going to do greater than 3. So here we have the absolute value of x minus 2 is greater than 3. So what we're saying is what values of x will be able to go into that equation or inequality so that the distance away from 0 is larger than 3. So again, I go off here and I think, what numbers are more than 3 from 0? Well, 4 is, 5 is, 6 is, so all of these things up here and forever will be more than 3 away from 0, but so are all these numbers on this direction. Those are also more than 3 away from 0. So now in this case, you don't have any overlap of numbers. So you don't have any numbers, a situation where two things have to be true at the same time. You have a situation where one thing is true or another thing is true. So this sets up two inequalities One is when x minus 2 is greater than 3. And then in this case, we use the word or because it's not two things that are happening as an overlap, it's two things that are happening independently of each other. So it's when x minus 2 is greater than 3 or when x minus 2 is less than negative 3. Then we solve each of these, so we have x is greater than 5 or x is less than negative 1. That's our inequality version of that. What this looks like on a graph, because sometimes it's useful to see that, is all of the values that are greater than 5 or all of the values that are less than negative 1 will make that original inequality true. Hope this helps. I know it's just as it pertains to a few questions. The rest of them, I think, without absolute value are a little bit more straight.